Yeah, we are going to discuss here. So this is our topic. Like we have given this presentation in different summits and in the programs. This is like events in action with Spinnaker, Jenkins, Tekton, and Keptn. So we are actually me and I'm Jalandhar Ramagiri, and so along with me I have Adam here.
Hi, I'm Adam.
Yeah, so we are working on CDEvents project. So that's the new project in the Continuous Delivery Foundation. So that helps to interact with different CI/CD tools using events. So CDEvents is a common specification for continuous delivery events. So we have built a POC initially using Spinnaker, Tekton, and Keptn, and we have something like noticed Jenkins is having something is using Eiffel events in our environment. So we wanted to bring that Jenkins into also the CD event space where it is able to communicate with the CD events supported tools. So we have built something like an event translator so that Jenkins uses to convert Eiffel events into CD event and then communicate with Spinnaker, Tekton, and Keptn all together. So this is what we wanted to show something here. And so we have this agenda. So quickly, like before jumping into the like Eiffel event translator and everything. So we wanted to show in the high level of what is continuous integration and deployment, and why we chosen this CD events approach that we will say example like with interoperability versus integration. So which will be the best suit for the communicating with different CI/CD tools. And we have like a CD events next we can talk about. So what exactly the CD events and what specifications it has to interact with different CI/CD tools. And we have the Eiffel events mapping. So we'll show like what event types from Eiffel events will be mapped to what events of CD events, and where exactly this is helpful that we can discuss. And the next one is events in action with CI/CD tools, something it will show in action. So wherein like different tools are communicating using CD events altogether. And so we have a demo, live demo, so that Adam will be showing after this discussion. So we'll jump in. So this is like the general thing what everybody knows, like what is CI/CD, right? So we have CI/CD is a continuous process, right? So where you do plan, code, build, testing, and release, deploy, operate, and monitor. So we can see like at each stage, right? So we'll have different tools to automate the process. When you are doing like coding, build, test, release. So we have many tools that is involved here. So that tools needs to communicate with each other to go this CI/CD process fine without any issues, right? So we wanted to discuss about the tools that is involved here, basically. So here, the Continuous Delivery Foundation is the one. It helps or it hosts the projects related to continuous integration and deployment. And we can see this is the typical workflow in any of the application that happens. Like if you see any software code change happens, so that initially it goes for a building that an application, and we wanted the next stage will be like deploy that application in staging location. And after that, like if you on staging, so you'll be running some um, tests. Yeah, so so running some tests on using the deployed application in the staging, and you do some quality checks before deploys in production. So the final stage will be deploy in production. So this is the typical workflow happens in every application that is going on, some changes in every day to day. So let's say like different tools are involved in this process. Let's say the Tekton. So Tekton is building an application. Take an example. And Spinnaker is another CI/CD tools that deploys an application in staging location. And Jenkins is the one, so it runs some test to make sure the deployed application in staging is working fine with few unit testing and things. With few automation testing and everything. And Keptn is another CI/CD tool. It orchestrates and do the quality checks before deploying in production. And we use Tekton again to deploy the application in production back. So in this stage, like we wanted to see like how these tools will communicate with each other, right? So that's the crucial part here. So we have two options, like either we can achieve. So we have these Tekton, Spinnaker, Jenkins, and Keptn, right? So we can use interoperability. So that means each tools that you can see here uh, talks same language. I mean, speaks the same language so that they can understand each other. So it's something like they need a common language to communicate with each other. Whereas integration is more like having a conversation through an interpreter. So it's something like having a glue code or a code specific to a component that should be there to talk to another component in this CI/CD ecosystem. So let's say like it's simple like in English. If two people are meeting, like unknown people, so if they wanted to communicate with each other, so they should be knowing some common language so that we can say that is English. So if they are not knowing the same language, so we need someone who can translate their own language into something else so they can understand each other. So it's something like this. We can uh, decide like what is interoperability and integration. So here, events in place enables interoperability between the different CI system tools. So we are using cloud events here to have this communication happen because cloud events enables interoperability. It can send an event to another CI/CD tools, and so that they can communicate without having any glue code between these components. So it's all interoperability. So Cloud Event is again hosted by the Cloud Native Computing Foundation, and it has a specification for describing a data in common way. Sorry. And but the thing is like Cloud Event is the one it already existing. So we are building a CD event on top of this. So we are not considering Cloud Event for CI/CD specific because it has a different formats and inconsistent semantics for CI/CD specific context. So that's why we build something like CD event. So CD event is the project under CDF, as I said. So it's a common specification for continuous delivery events. Um, net.
Monthly meet. Open source. మ్యూట్ చేశాను అదేంటి రావట్లేదు ఆడే మ్యూట్ అయ్యాడు
Sorry for that. Yeah. Sorry for that. Can you hear me?
Yeah, we hear you fine.
Yeah,
we can hear you.
Yeah. So we use CD events is a common specification for continuous delivery events. I said so. We are using cloud event bindings for CD events. So that means you can see. So the CD event looks like in this format. So you see the black portion of this is something is added to CI/CD context. So the artifact ID, artifact name, artifact version is something related to the CI/CD context. But the rest of the blue content you see it is a cloud event specification. So we are building a specification. So we have a special interest group. Special interest group. Um, CD events, so that is focused on creating. Yeah, so that is focused on creating a specification for continuous delivery events. So we the specifications are divided into four categories. Sorry, there's something. Yep. Yeah, so the specification is divided into four categories. We can say core and source code version control and continuous integration and deployment. So each one have different event types in it. So we see the example above is shown is the type of the continuous integration. So where you can see the artifact ID, artifact name, artifact versions are the different attributes that has for the artifact created event type or artifact from the continuous integration. Yeah, so Also, CDEvent is having some SDK supported to integrate different CI/CD technologies with CDEvents. So we have Go SDK and Java SDK, and so many are building by community like Python SDK and other things are coming in. So this is about CDEvents and specifically, and if you talk about like what exactly the CDEvent and it can express is a specific context, a specific CI/CD context. Like I said, so it can be something like an artifact is packaged, or pipeline run finished, or test suite is finished, or service deployed, or artifact is published. So we'll have different platforms can be integrated using these events. And so these are the communities engaged with the events currently. So this is like something a CDEvent can produce different types of events. So something like artifact package, like I said. So using this, we have different Eiffel event types mapped with this. So Eiffel events is something, like I just put something. It's a protocol for machine-to-machine communication, like and this is again focused on CI/CD use cases, right? So we have built something like an event translator to match different Eiffel event types to CD events. So let's some of the example I have put here, like Eiffel activity started event is mapped to something like in CD events, like dev.cdevents task run started. So similarly, we have other Eiffel events, so that are mapped to CD events. So the event translator in the middle, so this helps to translate so events from Eiffel events to CD events and the vice versa. And this actually enables interoperability between Eiffel and CD event supported tools. So it's actually the use case comes in when let's say Eiffel event supported systems are already in production. If they want to communicate with the tools that are supporting with CD events, so they can have the translator in the middle, and they can convert the Eiffel event into CD events, and CD events systems can talk to the Eiffel event supported systems. So that's the main idea of this. And so this is the overall picture, like using interoperability we can enable CD events. So CD event is the one like we explained with the CI/CD context and specification. So using that, so we can enable interoperability between these CI/CD tools. So we can see each. So we have a POC developed. So with these tools. So we are using CD events basically, but only the part is the Jenkins is the one is producing Eiffel events here, and so that we will be converting into CD event, and so that this can be talked to other tools in the system with Spinnaker and Tekton and Keptn. So to talk about like little bit on the each component here. So Tekton is a cloud native solution for building CI/CD system. So we in the POC we use to build an artifact. So that means like any changes happening. So we will just build an application using Tekton, and Spinnaker is the one. So this one, it's a multi-cloud continuous delivery platform. So we can run some pipelines using this Spinnaker again. So here we are using in the POC we are using Spinnaker to deploy the build application into the staging location. So that is built by Tekton. So Tekton will communicate with Spinnaker saying that artifact is built. And Spinnaker takes that artifact and then deploy in staging location. And Jenkins is the one we are using, like I said, on the Eiffel side. So this will communicate with Spinnaker again. So because CD events is the one now it is producing CD. Spinnaker is the one it is producing CD events. So that will be converted into Eiffel event to be understood by the Jenkins. So now Spinnaker will produce in CD event and convert it. So that will be converted to Eiffel event by using event translator, and Jenkins will be picking that event. So once Spinnaker is produced. So Jenkins here we are using, like I said, to run some tests and see like if whether the deployed application is working fine or not. And so on the other side, we have Keptn. So this is another CI/CD tool. So this will help to orchestrate the different CI/CD tools within the CI/CD ecosystem. So we have in the POC, so we have some sequence to manually approve the artifact that is built by Tekton, deployed in staging by Spinnaker, and tested by Jenkins. So finally, it will be approved by Keptn. And after that, so we will use Tekton again to deploy that application in production. So we can see all that in demo in action. So that's the demo. It will be shown by Adam. And we have next Knative. So this is the core part of it. So this we use for event-driven mechanism. So this is the one will have the subscriptions created. I mean, like triggers or subscriptions we can call as triggers will be created, and these triggers will be registered by the CI/CD, different CI/CD tools to communicate with. So this will actually have the CDEvents subscriptions created on Knative eventing. So the final one is like RabbitMQ. So this one we are using on the Eiffel message queue exchange system. So this will exchange the Eiffel messages in the POC that we can see. So it works as the publisher and consumer model. So we can see the functional diagram in detail, actually how it looks like. So how CI/CD tools will interact with each other. Right. So we have, so this is the Knative eventing that I'm talking about in the previous slide. So the green box is like what you see is the Knative eventing. So the middle we have the cloud event broker, and this is the responsible to receive the format of CD events in this case. And we have different triggers. If you see here, it's created. So these triggers are different type of CD events, and this will be subscribed to different CI/CD tools in the CI/CD ecosystem. So let's take in this POC the example, like so one of these triggers is subscribed by Tekton. So Tekton has a component like Tekton triggers. So CDEvents is subscribed to. So one trigger is subscribed to Tekton, and Tekton is also capable of producing a CD event, and that event is consumed by Cloud Events Broker again, and this event is passed to Cloud Event Broker, and this event will be acted as a trigger again, and whoever is registered to the published trigger, so the other one will be notified. So let's take an example. So this is another trigger that is available in the Cloud Event Broker. So now Keptn is registered to this type of trigger. So Keptn gets notified, and Keptn runs some jobs or things like that. So and Keptn also capable of sending an event here, CD event. So this is like an exchange of CD events between the tools. So Tekton sends something and then can be received by Keptn, and Keptn sends again. So you can see the Spinnaker again. That's the another trigger, and Spinnaker can subscribe to that. So this is how the flow goes. Like whoever is producing, so they can consume the type of events that they are interested in. Right. So similarly, we have the trigger in the bottom line. So even that also it's another trigger, so that is produced by some other component, let's say, and that we wanted to convert into event like Eiffel events. So that will be converted by using an event translator. And this event translator converts the CD event to Eiffel event in the first phase, and so that will be sent to the RabbitMQ broker, and which in turn has a subscriptions that is configured by Jenkins. So it will have subscriptions created to Jenkins to run some specific jobs, and Jenkins API will run some jobs and then sends back. And Jenkins also is capable of sending an Eiffel event, right? So it can send an Eiffel event back to the RabbitMQ message broker, and that itself, like we are again translating back to CDEvent and submitting that to Cloud Event Broker. So this is how the Jenkins sitting on the other side, it has Eiffel event producing and consuming part, but it can talk to the systems that is having CD events consumable and produce. So this is how like we wanted to show in the demo as well. So before going to the actual demo, so we'll flash. Yeah, so this is another one. So I missed the red part. You see, this is the Cloud Event player. Actually, we can see all the events going in and out between with the cloud events broker, so that we can see like the types of events CD events are flowing. So it's just a visual representation so that we can see in the UI. So before going to the actual demo, so we wanted to explain like what we are going to show as a use case. So we have 4 components here, like Tekton, Spinnaker, Jenkins, and Keptn. So Tekton, Spinnaker, and Keptn are producing CD events, like you see, and consuming, producing CD events. But Jenkins is the one is having producing and consuming Eiffel events. So, but in turn, it will be translated into CD events so that it can also, that means using an event translator. In now Jenkins also can produce CD events. So something like that. So we have a use case, something like this. A user runs a build on Tekton, so to build an application or something. So once the pipeline build is finished, or it is success, Tekton sends a CD event, so that is artifact packaged type CD event, and that is subscribed by Spinnaker here. And Spinnaker gets a notification saying that I got an artifact packaged event, so I need to do something. So that means like Spinnaker runs a pipeline to deploy that artifact in staging location. So once the Spinnaker deploys and Spinnaker pipeline is run success, and Spinnaker can send an event, something like pipeline run finished, a CD event. So that's the CD event type. And so this pipeline run finished event in turn, it actually will be translated to CD event and sent to. So Jenkins is subscribed to listen to that pipeline run finished event. So this is the format of Eiffel event the Jenkins is listening to, but whatever Spinnaker is sending, so it will be translated and sending. So now Jenkins gets a event, so that is the Eiffel event format, and it runs some test suits, which is on top of whatever the Spinnaker deployed in staging application. So once the Jenkins is finished the job, so it can send an Eiffel event, and that will be translated into CD event again. So it just runs the build and sends a test suite finished event from Jenkins, and that will be converted again into CD event and sent to. So Keptn is subscribed to listen to that type of event, and Keptn gets a notification that some test suite is finished, so I want to go to the next stage. So the Keptn is the one is subscribed to that type of event here, and Keptn gets a notification and it runs some sequence to approve that artifact, so that we can see the demo. Manual approval process it is, and after that is done, so Keptn can send an event that is artifact published event that is back to Tekton. So Tekton again can run a deploy job. So once the deploy job is success, Tekton will send a notification or send a CD event, so that is services deployed, and that is subscribed by Keptn again, and so the Keptn will mark the build sequence as successful. So this flow, everything that we can see in the demo right now. I think Adam, if you are ready, can you take the share and start so that we can take any questions after the demo?
There we go. You guys all see in my screen? Go. All right, start itself.
Yes.
Sorry, just.
This is the Tekton CLI. Just to explain, like we are using a Tekton pipeline start build artifact. So we are using the CLI Tekton pipeline to build an application so that we are going to check out from repo from this specific branch. So we'll be just pulling a source code from that Nordic cdevents repo and start the build, so that it will just build a Docker image and place it in the kind registry that we are giving an option here, like where it wants to play. So it's just in local, it will just place the application, whatever it builds, the latest one. So yeah, I think
And then we can show the cloud events. So it's sent a CD event for pipeline started and pipeline queued. And hold on. Yep, you can see it's running the build artifact there. It just takes a second.
So you can see the green things like it's cloning the repo and then image is built. I think we can see it with this SHA image ID with the SHA ID. So this is the latest one we can see that is just built. So we can verify at each stage or at each CI/CD component. So this is the one is getting deployed in staging, tested, and so all the way it is going on or not. So we can see that actually.
In this case, we're just going to keep in mind that the SHA ID ends in F005.
Yeah, so
Should have moved on to Spinnaker there after sending a CD event. So yeah, pipeline finished. Now we're entering Spinnaker fairly quickly. It should be Jenkins next.
yeah, like you see the Spinnaker pipeline is green now. That means it is deployed in staging already. You see half a minute ago. That is just quick. So I think, yeah, so after that, the Spinnaker gets, Jenkins get a notification by translating that Eiffel event into, CD event into Eiffel events. And here you can see the Jenkins build is triggered. So you can open the console and show Adam. Console logs, maybe. So is that the build it got just now? We can just see.
There we go.
Yeah, so we can see it's actually trying to build something. F005 is something it got, the latest one. And this is again sending an event back to the RabbitMQ broker. So that is Eiffel test suite finished event.
Test suite
finished. Yeah. And this will be taken by Keptn. So Keptn get a notification saying that so something is tested, whether I want to approve or not. So here you can see that with ending with SHA ID F005. So that's the one like I want to approve or not. So I can decide, and it's just a manual approval, so nothing verifying. But yeah, so we can just click and yes. And the next stage will be deployment is going on. So that means notification sent back to Tekton, and Tekton starts the deploy job. And we can see the pipeline run started and from the Tekton, and it will be deployed. So I think so. There are multiple deploy jobs, but I think if one is successful, so other will be ignored. So that there is some issue with the Tekton pipeline space. Yeah, but we can see once the build is successful, even in the POC application is deployed or not. Yeah, I think Keptn gets it right. Adam?
Yep.
So Keptn get a notification that the service is deployed fine. So and Keptn marks the sequence as successful. Here you can see in the Keptn.
Yep. Delivery successful.
Yeah.
Successful.
Yeah. So this actually deploys in a Kubernetes cluster. So we have a kind cluster created locally. So all that it will deploy in there. I think you can open the pod, and so it's on the POC. Yeah. Not this one. Okay, that's the staging one. Yeah. Okay. Yeah, you can show.
Here's
No, you can show the application. Yeah.
oh yeah. There you go.
So this is a simple page, the Docker image that built, and then we launch it here so that it is deployed successfully, that we can see. Yeah. Any questions you have? So this is the deployed application in production that we can see, with including like working all CI/CD tools working together with Eiffel and CDEvents. So the Jenkins is producing and consuming Eiffel events, but other tools with CDEvents working. So we have event translator in the middle that you can see, the yellow part. So that's the one, is the man in middle, converting all the events and sending it to one another. Any questions we can answer, we can take here.
So I'm thinking of observability within this pipeline. Is there any, you're showing the happy path. What if some component in this pipeline is dropping events on the floor, or builds fail, or how can you get some kind of help from cloud event tooling or something to see when things go wrong, or
so we actually used to debug something like, so whenever if some build is failing or something, right? So the event will not be produced in our case, right? So the event will not be even like once after successful pipeline is built, only we'll send another event to proceed with something on the next component. Let's say in this case, so Spinnaker is deploying the application in staging, so that pipeline is running. So if that pipeline itself is failing, so we'll not be sending the pipeline run finished event to the cloud event broker. So we can debug like why the event is, why the pipeline run is failed, things like that from Spinnaker side, and continue with the things, I guess. Yeah. So otherwise, so event will not be in within the cloud event broker if Spinnaker pipeline is failed.
it does require that you know quite a bit about how the pipeline is set up and then who is supposed to be responding to events. There's no, you don't get any extra help from the tools in this case.
So from cloud event tools.
Yeah, or from anywhere. I mean, it's sort of you can debug it if you know where to look, I guess.
So I think we have. Yeah, man.
You can go ahead, Jalan.
Yeah, I think we have like this cloud event player also that we have, right? So that helps in having all the events in place, right? So we can even debug from there if any event is at least arised within the cloud event broker or not. So the cloud event player one we are using here, so to have every event to pass in. So I mean, like cloud event player gets every event that is there in the CI/CD process. Yeah.
Okay, so that's both a player and a recorder then.
Sorry.
I mean, I thought you could use Cloud Events Player for sending new events, but it also actually records the events that are sent by other parties.
Yes.
You can look at them. Okay.
Yeah.
So I guess it's maybe not very easy to follow the flow just by looking at the Cloud Events player there, but if you would have some higher level visualization or something on top of it,
yep.
And you would then know what is your overall end-to-end orchestration, what does it look like, then you would see now the flow stopped after this cloud event, so therefore something has happened within Spinnaker or wherever that the gap would be. So you would of course need to know what different components are part of your end-to-end pipeline in this case.
Yeah, that's correct. So something like visualization is coming on the next POC. I think that's in our backlog. So that's visualization will help to debug more in that case, like Emil said. Yeah. So
I have a question.
yes.
So is there any reason for using both the CDEvents and Eiffel Events, or is it just like a result of what the components used before, or
It's just so we know, like now in something like in production, let's say the Jenkins is already producing and consuming Eiffel events. If we don't want to disturb that environment, so we can use something like an event translator on top of that to not to disturb the existing things and use as is by this using this converter tool. Yeah.
okay, so it's a result of an already existing architecture you have, right?
Yes. Yeah.
Or I can maybe complement. It's also a result of a request coming from me and others, maybe. That it would be great to see the interoperability here between CDEvents and Eiffel. See that it's, I mean, we're talking about two different event protocols, but they can actually interoperate with each other and integrate each other. So of course there is as well a Jenkins plugin for cloud events itself. There was a Google Summer of Code job performed last summer already where that was implemented. That has maybe not been maintained since then, but there is at least an embryo for it. So there is no need to actually use Eiffel Events for communicating with Jenkins here. It could instead have been done with CDEvents directly. So it is of course to prove that it's possible to have this kind of mappings between CDEvents and Eiffel. So it's very very simplistic yet, I guess. The actual translator there mostly translates the event names and some properties within them, some few properties. Great, thanks Solander and also Adam for the demo. Any more questions from anyone? Okay, I can maybe just complement that the CDEvents protocol is still very much a beta version. I'm one of the maintainers of that protocol or developers of it as well. We recently released the 0.1 version of the protocol, so we haven't really released the 1.0 yet, and there are no official plugins to any of these tools for CDEvents yet. It's just proof of concept implementations still. But we foresee that this will come within a year or so. There will be a 1.0 version, we hope. I'll stop the recording there.